Section 4.2, constant percentage change. It's a good idea if you take notes. We learned already that when a is greater than 1, this factor has a name growth factor. And we have to use the formula a equal to 1 plus r. R is a new variable. So you have to remember that R is a rate, and it always has percent sign, and you always have to change rate into the decimal by dividing by 100%. If your A is greater than 0, but less than 1, this factor has a name decay factor, and you have to use the formula A equal to 1 minus R, and R is again a rate in percent, and you have to change percent into a decimal. All this section is about reading. When you read the problems, pay attention to words that you are reading. Here is the first example. An exponential function has a growth factor of 1.09. What is the percentage growth rate? Let's read. An exponential function has a growth factor of 1.09. What variable do we use for word factor? It's a. So a is equal to 1.09. Why do they use word growth? Because our factor is greater than 1. If it's growth, what formula will we use? The formula is a equal to 1 plus r. What do we need to find? The percentage growth rate. Do you see word rate? What letter do we use for word rate? R. So we need to find R, and do you see this word? Percentage. So your answer has to be in percent. How will we do it? We know the formula already. We will substitute A into this formula, and we will find R. So it will be 1.09 is equal to 1 plus R, a simple linear equation. So we will subtract 1 from both sides, and our R will be 0.09, but this is our decimal, and we said that at the end we want to have a percent. How will we change decimal to the percent? We will multiply this number by 100%, or move your decimal point 2 places to the right, and the answer is 9%. So if you read the problem carefully and think logically, this problem is not hard at all. Next example. An exponential function has a decay factor of 0.70. Or what is the percentage decay rate? Okay, let's read again. An exponential function has a decay factor of 0.70. It's a good idea to read the problem and underline the important words. Decay factor. What letter do we use for factor? It is A. It means A equal to 0.7. Decay factor. Decay means we will use the formula A equal to 1 minus R. This you have to memorize. What is the percentage decay rate? So we need to find rate. What letter do we use for rate? It's R. We need to find it, and it has to be in percent. How will we do it? Again, When we read the problem and write it down everything that we understood from the problem, it's easy to see. We need to take 0.7, substitute here for A, and find R. There are some tricks there, so let's do it carefully. 0.70 is equal to 1 minus R. We will subtract 1 from both sides. It's a good idea if you type it on a calculator. 0.70 minus 1, it will be negative 0.30. Don't lose this negative sign. It has to be here in front of R. I'm sorry, this is my R, not the best one. We have two negative signs. We have to divide by -1. So your R in this case is 0.30. Now we have to change the decimal number into the percent by multiplying this number by 100% or moving the decimal point 2 places to the right. So the final answer will be 30%. When you work on similar problems, please do it slowly and carefully so you will not make mistakes and save your time. Example number 3. A certain population has a yearly per capita growth rate of 1.2% and the initial value is 5 million. Use the formula to express the population as an exponential function. Okay, if we need to find an exponential function, we need to use a formula. N is equal to P times A to the T power. P is initial value. Do we know the initial value in this problem? Read the problem again. And you see it right here. The initial value is 5 million. It means my P is equal to 5. It's given to us. Our problem is not so hard. Do we know A? A is our factor. We know this, then we have to read and find important things. Growth rate. And I don't see any numbers for factor. The only thing that I know is that it's growth. It's important. But I don't know it. It's not given to me. What is given to me? Rate of 1.2%. So my R is 1.2%. And remember, we have to change it to decimal. Divide by 100%. Or move your decimal point 2 places to the left, so it will be 0.012. This is my rate. But now I can find the factor. Remember, the factor, it's growth, so we have to use the formula A equal to 1 plus R. We know R, we will substitute R into the formula, so A equal 1 plus 0.012, and my A is 1.012. Now we know P, we know A, it's ready to write the formula down. The formula will be N is equal to 5 times, I like write it down this way, to the T power. The reason why I like to put parentheses, so I like to make everything visual. And in this case, I will see that 1.012 is my factor and 5 is my initial value. I just like to make everything visual. Now we know the equation. And we need to express using functional notation the population after 4 years. I hope you remember how to do this. You have to write it down this way, n of 4. This is our functional notation. I just want you to keep this in mind and don't forget this part. C, we have to calculate n of 4. How will we do it? We will just substitute 4 for t into the formula. 1.012 to the 4th power. I would recommend you to type this expression from beginning to the end on your calculator. You have nice calculators, and calculate, so it will be 5.24 million. And we're talking about population, I will say people. I hope this problem was not hard for you.